What is up, my peeps from the intertubes? It is Caleb from Caleb the Video Maker 2, and this is your first video over Db2. Now, Db2 is a database that was created by IBM. Historically, it's been marketed largely towards enterprise customers, so think, companies that have more data than they would ever possibly know what to do with. But lately, they've been focusing a lot more on developers. So they've given new features and new additions to meet the needs of developers like me and you. To make sure we are all on the same page, let's answer the question, what is a database? The classic example of a database is a user using some application. And just be warned, I literally have the worst drawing skills of all time. So here is some user using an application, and when he types information in there, it's going to get stored inside of a database. And this is kind of like the typical drawing for a database, except way better. So he inputs info, and that's stored in a database. So the database is usually hidden from the user. And then, when this user comes back and accesses that application at a later time, we can actually get that information back from the database, display it on the application, which will be seen by the user. So this kind of setup here is good for transactional data. So if I said something like we're doing transactional processing, I want you to think input, output, updating, deleting. So this user inserts data, he gets that data back out. The other use for a database is analytics. Analytics looks at all of the data or parts of the data rather than just one insert or one select. So the analytics are used to make business decisions. Running analytics will give us averages, trends, all of that good stuff, and we can use that to shape the direction of where we're taking our company. If customers like one thing but don't like something else, well, we can match our company and our content with what they like. So these are the two primary uses for databases, and fortunately, Db2 is suitable for both of these. We are going to start with transactional processing, but Db2 is awesome when it comes to analytics. Generally though, if you're new to databases, you will want to start with transactional. So that's learning how to work with data. How do we insert data into a database? How do we get the data back out? How do we update it? And how do we delete it? Db2 is well known as a relational database. And what that means is it works with structured data. The other kind of data out there is unstructured data. Just like Db2 works well with transactional and analytical processing, Db2 does support both structured and unstructured data. And if you're new to databases, that's probably not going to make any sense at all. So the easiest way to illustrate this is with a very simple example. When we are working with a relational database, we represent our data in tables. So this is a table and it's going to have a name, for example, users. And then we're going to have columns. These columns define the structure of our data. Every single user in here is going to have the structure made by this table. So a user ID, first name, and last name. This is structured data. Unstructured data does not follow table rules. We are going to start with treating Db2 as a relational database, so we are going to learn about creating tables and the columns, the rows, and how to connect tables and all that stuff. But as you get more advanced, you can work with unstructured data inside of Db2. It's generally well known today that if you're going to have any successful application or business, you are going to need a database. That being said, I do just want to take a couple seconds to focus on the basics and really think, why do we need a database? And I have two good reasons. The first one is security. So the security capabilities with the database are tremendous. A general rule in computer science is that you don't trust anyone ever for anything. So with a database, you can be very specific about who gets to see what. The other thing is scalability. This refers to the capability of expanding your data layer of your application or business. So as your company grows, Db2 has many additions that allow you to scale up to even an enterprise edition. So we talked about a couple things for general databases, security and scalability, but now let's talk a little bit about Db2 and why you would want to use that. The very first reason why I like Db2 is that there's a free version, and as you all know, I'm a total tightwad. The other reason is something called Blue Acceleration. This deals with the analytics side of Db2. I mentioned a little bit ago that Db2 has some awesome things when it comes to analytics. Well, this is specifically what I was referring about. This is an in-memory processor. So essentially we bring our data into RAM, and then we can run crazy fast analytics on our data. There's a plethora of other reasons why I think DB2 is a good database. So if you are starting a project and you're trying to decide what database to go with DB2. On top of that, this series is going to give you the foundation needed to build a DB2 database. If you guys have any questions, concerns, or comments, just leave them in the comments below and I will do my best to get back to you. On top of that, I created blog posts for these videos, so I will put the link to that in the description. Finally, if you actually want to give DB2 a try, I'll put the link to get that in the description as well. Be sure to subscribe because there's going to be a lot of great content coming out. We're doing some concept stuff up here and then some coding down on the computer, so we get, the concepts and the practical. We get, I'm super excited. Hopefully you guys are as well. And as always, be sure to subscribe and I'll see you in the next video. Peace! Welcome back, guys, to your second DB2 tutorial. Now, I'm going to go a little bit into the basics of DB2. So I'm not really going to go into how to install it and all that because that's really super boring. But I am going to tell you where to install it. So I made this handy dandy link right here. Just go to bit.ly/DB2 Community Edition. And that is a very convenient link. Secretly, I want to track you. That'll take you to this page and you can see my beautiful face. Anyways, you can click this download now button. And as you can tell, my internet is extremely fast. Once you get to this page, it's going to ask you to sign in and then it'll give you some options. And just download the full thing. When you are deploying, you can get smaller versions of DB2 without all the extra tools and stuff. But since we're developing, we're just going to get everything. So once you're here, sign in. If you're a first-time user, click yes, and then make sure you read that good book, and then click I agree. Then what you want to do is download the version according to what operating system you're on. So I am going to go with the Mac version right here. When you download it, you're going to go through the installation process. It'll ask you for a DB2 user and also a user for something called Data Server Manager, which I'll talk about all of that, but just make sure you write all that information down. Going through the installation, you're going to install something called Docker, and it has this cool little boat whale logo thingy. And this is a container software. If you don't know anything about containerization, well, we're on the same page. But essentially, it's just a way to have a consistent infrastructure for your applications. It's kind of like a virtual machine, except it doesn't have the entire operating system, if that helps you understand it any. Anywho, I think I'm getting into way too much detail. The most important thing is that you get to this page here. So when you get here, you'll want to use your Data Server Manager username and password. Once you get in, you're going to want to put your DB2 credentials, so I believe it was db2inst1, and then just whatever password, and then you can click Save Credentials to Repository and click OK. There are all kinds of things you can do with this tool. Generally, Data Server Manager is the tool used to manage your database, so there's all kinds of administration, monitoring, and all kinds of other fancy things in here. I just wanted to point out a couple things. So if you go into Administer and then Tables, you're going to see all of your tables. So if you click a specific table, you can go in here and click this data button. That's going to show you the data of the table. So this will allow you to see the columns and the data types and all the data inside of it. This will help you see the way our data is represented in a relational database. Another thing you can do is run SQL or SQL. This is where you're going to type in all of your commands to communicate to the database. A couple other things is you can click this little hamburger panel thingy majig, I don't know. Click that and click Data Studio. Now this Data Studio is an optional thing you can install, but I would highly recommend it, especially if you're going to be doing anything with stored procedures. When you open it, you're going to get prompted with this right here. And you can think of this as kind of like Eclipse. And if you don't know what Eclipse is, it's just an IDE used for programming. So you can click OK. It looks kind of funny because we're in this virtual machine sort of thing. But once you have it open, you get used to it and it's really not so bad. So you can go in here and you can connect to your database here. So you can use this tool if you want to get more into the development. I'm sure there are a ton of tutorials online. This is not going to be the start of my focus. I just wanted to show you that so you know what it is and how to get into it. So let's go back and let's look at the connection details. One interesting thing here is if you scroll down, you can click this little link here. And this will allow you to use Data Server Manager in the browser. There you go, and you can change your database up here, so I can go back to the sample database. And yeah, that's that. Let's go back to the windowed version. And that's basically all I really have to say to start you off. In the upcoming videos, we'll be running all of our commands in this run SQL panel, so you are good to go. Thank you for watching, guys, and I'll see you in the next video where we'll start talking about some more concepts, and then we'll come back and learn some hands-on things. So, see you then. Welcome back to your third Db2 tutorial. In this video, we are going to be talking about data structure. So, we've gotten our hands and feet wet a little bit in the previous video, but now, before you go making a fool of yourself, you should have some general things in your mind so that you don't make yourself look like an idiot, right? So that's what this video is for, to make you not look like an idiot. Essentially, the goal is to teach you the very basics of data structure and data types. Let's start with data structure. Now, in the first video of this series, we talked about structured and unstructured data. That's not exactly what I'm talking about. I'm talking about if you just zoom out a little bit and you look at the big picture of your database. So if we represent our database here like this, and now I just want you to envision zooming in on the database. Okay, sort of like, you know, those movies where they zoom in on someone's arm or something and then it goes into their cells and all that cool stuff. That's what we're doing here. So you zoom in. Well, all of our content is going to be organized in schemas. So this is a very important word in DB2, and it's basically just a super fancy word for groups. So we can have multiple schemas in our database. These are just logical groupings. We can decide how we want to organize our tables by putting them in different schemas if we so desire. All right, now we're zooming in and we zoom in onto this schema. Well, now inside of this schema, we're going to have multiple tables. All these tables share a schema, but the tables themselves don't necessarily have to be related. Some of them might be using relationships. So when you have tables where the data is connected between tables somehow, this is known as a relationship. We are going to get into all the boring details of relationships, but we'll save that for another video. For now, just know that our data can be connected using relationships. Now, the way you structure these tables, well, generally a table describes one thing, and it's going to store multiple of those one things. So for example, users or vehicles. But you never combine multiple things in one table. For example, putting the users and the vehicles in one table, you just don't do that. You'll understand why later, but for now just understand that every single table describes one individual kind of thing. So we'll see that more as we zoom in on a specific table. Well, let's say we zoom in right here, and I'll bring that down here. Well, we might be looking at this table right here, and we'll say this is the users table. Inside of this table, we're going to have columns. So the columns go this way, and generally we're going to have a column header, the name of the column. So for example, we can have the user ID. And now every single entry in this table is going to be a new user. So we can have one, some data, and so forth. That is one specific user. And then we can have another user. These that go this way are called rows. I don't really know what this zooming illustration is helping with, but I just like to visualize zooming deeper and deeper into the structure of our database. When we zoom into this column, I'll make it extra big. Well, this is going to have a data type. A data type is just a type of data, as you could probably figure out from the name. Essentially, there are restrictions on what kind of data we allow in this column. So there are different categories of data types that we are going to discuss in this video. There are a lot of data types, and it's important you don't spend years and years studying the data types before you really understand databases in general. So what I recommend is you learn the basics of data types, then learn all the other things with databases, and then come back and learn all the details with the data types. The very first thing you're going to want to start with is the data type categories. So these are the general categories for data types. This is pretty universal, so any kind of relational database is going to have data types in these categories. So when we talk about numeric, that means anything dealing with numbers. Strings, on the other hand, are characters, you know, like things you type on the keyboard, spaces, tabs, all that good stuff. And generally you represent these using quotes, either a single quote or a double quote. Generally for databases we use a single quote, so I could say something like this. This is an example of a string. Temporal, this deals with dates and times. Once you got these categories down, there are some very specific data types that go in these categories that you should know. I'll be explaining some of the data types we'll be using in the upcoming videos. That way when it comes up, I don't have to spend a lot of time explaining what everything means. The very first data type that I would like to share with you is called int. So int is short for integer. Anytime we're dealing with integers, we are talking about whole numbers. So like 16. If you had 16.07, for example, that's not a whole number because you have a fractional part. So this is not an integer. This, though, is. So integer, whole number. The next is char and varchar. These deal with strings. There is a minor difference between char and varchar in that if you're dealing with a char column, all of the data for that column is going to be of the same length. So for example, 5 characters. Varchar, on the other hand, is designed to store variable length character data. So just think variable character. So that might be, a comment or something that's not always going to be the same length. The next is Boolean, or Boolean. This is designed to store something in 2 states. So usually this represents true or false. But you can interpret it how you want. On, off, yes, no, high, low, strong, weak, however you like, as long as it has 2 states. The next data types are date, time, and timestamp. These are the temporal data types. Date just stores a date. Temporal data types, history or in the future. Time will store a specific time of some day. It doesn't actually store the date part, so the date is irrelevant for this data type. Or you can have kind of like a combination of both in what's called a timestamp. So this is kind of just like an instant in time, past, present, or future. That is a general overview of data structure and how we are going to approach the next videos. Now that you have this under your belt, you will understand what it means when you have what's called a fully qualified name. So a fully qualified name looks like this. Schema.tablename. Now this obviously is an example, so it's general, but this is going to be some table name such as users, and then this is going to be whatever schema that table is a part of. This allows us to be very specific about what table we're talking about. That way, the database knows what schema we're in. So once again, this is called a qualified name. And in computer science, or maybe in real life, I don't know, when you qualify something, you basically prefix it with some more information so you know what we're talking about. So if you didn't qualify this table, it would just be users. But if you qualified it, you'd put schema.users. That's all I got for you guys, so thanks for watching. Be sure to check out the blog for this video, give Db2 a try, check out my website, subscribe, and as always, have a great day. Actually, I think that's the first time I've ever said that. I don't know. Well, in these videos, not ever. Okay, I'll see you in the next video. Please be sure to subscribe, and yeah, that's all. Welcome back, it's Caleb from Caleb the Video Maker 2. This video is going to be a pretty simple video on how to create tables and drop tables. So when we're talking about deleting tables, we use the keyword drop, not delete. So they are both keywords in SQL, so you got to make sure you understand the difference. Drop is part of the structure, so if you drop a table, you are getting rid of it from the structure. Delete, on the other hand, is used for data, and that's to delete data from a table. Just a little tip there so you understand the difference. So we are going to start with creating a table. Now because we're just starting and we don't have a lot of SQL skills under our belt, I'm going to paste a little script in here and then just explain it rather than type everything from scratch. So here's an example of how you create a table. We are creating a table called users, and this syntax is very simple. You just say create table and then the name of the table, and then inside of parentheses is all of the columns that you're going to put in the table. Then you end the statement with a semicolon. This allows you to go put more statements after this statement. Each one of these here is a column. And the syntax is the name of the column followed by the data type, which is just what kind of data we want to store in that column. Overall, the statement is pretty simple, so if you're having any issues, I think over time you'll just kind of get used to the way we write SQL. Once you have the statement finished, you can hold Control and press S, even on a Mac. And okay, we have an issue. Let's figure out what it is. I bet you it's because I already created this table at one point. So I will give you a sneak peek and show you how to drop tables. Just like that. All right, I ran that and you could see it worked. Now let's go back and create this table. And you can see that worked. If you ever do have an error, you can click this little arrow. And let me just expand this a bit so you can see. You can click this little log button, and that's going to give you some more information where you can learn about this error, and that will open a web browser. When it loads, it's going to open the IBM Db2 docs, specifically for Linux, Unix, and Windows. You gotta be careful when you open any document pages on the internet to make sure you're on the right version of Db2. So let's go back and let's just learn a little bit more. The first thing is that SQL is not space sensitive. The more technical term is it's not white space sensitive. So white spaces include tabs, spaces, and enters. So you can structure this however you like and it's going to work just the same. So just to show you this, I'll drop the table, then I'll rerun this create table statement with all the extra white space, and you can see it still runs. Now there's obviously some rules to this. You can't split keywords like this, and anytime you're dealing with something like a string, any extra spaces in here are going to be part of that string. So it doesn't always work that way, it just depends on the context. If you are writing SQL and you're not dealing with splitting words or strings, then everything should be fine and you can structure it however you like. So if you prefer everything to be on one line, go right ahead. As a sneak peek towards the future, when we start talking about primary keys, you're often going to have one column designated as the primary key. And that is a special column that is always going to be unique and determines how the table is stored. So if you make this ID column the primary key, when you go and get the data from the table, it's going to be sorted by the ID. So to make something the primary key, it's really super easy. You just add in here primary key. Now there is one other thing you need to do, and that is label it as not null. So that means you're not allowed to have nulls. Nulls are the absence of values. So when we say not null, we're literally just saying every single row has to have a value. So let me drop this table and recreate it with the primary key. There we go. So now if we go to administer and then tables, we should be able to find our user table. There you go, and you can see it's part of the db2 inst1 schema. So I didn't specify a schema, so it just defaulted to db2 inst1. If I wanted to specify a schema, I would just prefix my table with a name of a schema. So let's go to the users, and then we can go to columns. We can see all of the columns and their data types. We can also look at the data, and you can see that there's nothing in here. So yeah guys, that is your introduction on creating and dropping tables. Hopefully that was helpful, and in the next video we'll be doing something else that will also be extremely exciting. So be sure to check that out, and thank you for watching. And be sure to subscribe, check the description for any notes or links or anything cool like that. Welcome back everyone. This video we are going to be discussing inserting data into a DB2 database. So we created this table and I just left it there so you can see the structure of how we created it, just in case you jumped in the middle of the series and you need to create the table. Just run this SQL and you should be up to speed. So when we insert data into a table, it's very important that we know the table structure. So there's two real ways you can do that. You can go to the table in here and you can find it in the table explorer, users, and then go to either columns here or going to data here and seeing the names of the columns. And this will also tell you the data type so you know what kind of data to put into the column. So let's go back to SQL and I'll teach you the other way. Select star from users. And just so you guys are aware of the capitalization standards, anytime we have keywords, they're in all capital letters. So create, table, varchar, all of those are capital. Anytime we're referring to something we created, we use lowercase letters, users. Now let's run this, and this is going to select every column from the users table. You can go down here and click results set, and you can see the columns right here. This is a little bit more handy if you do not have Data Server Manager to help you find the columns. This will help you do it in code. So once you have that table structure, we can coordinate our data that we're inserting into the table with those columns. So to insert data, what we do is we use an insert statement. So let me just get some extra space here. And the way you do this is insert into, and then you say the table name, so users. Then on the next line, I usually go to the next line, but you don't have to. Values, and then parentheses. This is the general structure. Inside of these parentheses is where the data is going to go, and it has to match this structure. So the very first thing is going to be the user ID, and it's a number, so we don't quote it or anything. The next thing is going to be the first name, Caleb, and we separate all of these data pieces by commas. Then curry, and we'll go with caleb@email.com. is verified. This is going to be a Boolean, which is just true or false in this case. So, comma, and then we can actually get a timestamp value very easily by using the keyword current timestamp. And then lastly, I'm going to put a semicolon at the end of our statement, and let's run it by holding Control and pressing S. And you can see it worked. Now if we go back up and run this select statement again, boom, there you go, there's our data. I'm not quite done though, I want to do a couple more insert statements, so let's go back down here. The next thing I wanted to show you is that you can explicitly say what columns you're inserting into. And you'll see why that's useful in just a minute. So what you do is say insert into users, and then in parentheses what you do is you type the column names. And then you do the values again and you put data. And then a semicolon. And now let's run this, make sure it works. And you can see the insert did work. So the reason this is useful is because you can actually rearrange the columns now to say exactly how you want to insert the data. The end result is the same, but this just might be for personal preference if you want to rearrange the columns. So to show this, we're going to do a third insert statement, but we're going to change the order of the columns. Just to make this easy, I'm going to take all of these columns and I'm going to paste them right here, but now I'm going to rearrange them. I'm going to take these last two columns and I'm going to paste those right here. All right, let me just clean up a little bit. There we go. Now we can insert our values according to that column structure. So we could say, 3, true, current timestamp, Leah Smith, and then Leah, and then we'll give her an email, leah@email.com. Put the semicolon, and now we run this, and it worked. So you can see how versatile this is. We can do it just like we like. Another great reason for having the columns explicitly typed out like that is because sometimes you don't want to insert data into all of the columns. So I'll show you an example of that now. Let's just say we want to put the user ID, first name, and last name. So we'd say insert into users, and then we just say the columns that we want. And now we only have to put values for those columns, just like this. And it worked. But how does that work when it comes to viewing the data? Well, that's going to give us nulls. Nulls are the absence of values. This is how you make a comment, by the way, 2 hyphens. So expect to see that word in the future because it's very common and very popular in databases. So let's go back up to our select statement and see our data. There you go. So that is how you insert into a Db2 table. Thank you guys for watching, and I will see you in the next video. Peace, and don't forget to subscribe. Check the description for links and all that good stuff. See you in the next one. Welcome back. In this video, we are going to talk about selecting data from our Db2 tables. Now, what good is a table if you can't get the data back out that you put into it? That's why there is the select statement. So just to get some vocabulary correct, the select is an example of a statement, and the from is an example of a clause. So the clause kind of gives more information to the statement. Without this from, Db2 would have to just guess what table you're going to get your data from. And that requires mind reading, and unfortunately mind reading is only available in the enterprise editions, so you're going to have to settle with using that from clause. So the general structure is here goes the columns, and we just have a star, which in computer science this is known as a wildcard, which means basically anything. Anything goes when you have a star. The data right here is the table you are selecting from, so columns, tables. If there is any ambiguity on what table you are referring to, you can prefix it with the schema, db2 inst1.users. And you can see it works just the same. Check the result set. Yeah, there you go. But now instead of using this wildcard, I want to be specific on what I want to select from this database. So to do that, it's really super easy. Just go here and delete that star, the asterisk is what it's called, and just type the column names that you want to select. And you can actually do this in any order, so I could start with the email if I wanted. And now when we view our result set, you can see it only gives us the email first name and last name. Now you look at these columns and you think, oh, that's disgusting. Who would want to look at an underscore and blah? So there's actually ways you can change the way that these columns present themselves. And that's with what is known as an alias. So an alias is just a nickname for nickname. That's confusing. So we'll see that in practice and it'll make sense. So let's go up to our select statement and we're going to change the way this looks a little bit. I'm going to bring each column down on a new line so it's very easy to see. And then what you do is you use the as keyword. And then in double quotes, you say what you want it to show up as. So I'm just gonna say first name. So I got rid of those nasty underscores and it's gonna look really beautiful when I do my reporting. My boss is gonna love me, give me a promotion, and so forth. So in conclusion, always be sure to use the as keyword. Oh, we run that and we see we got an error. And let's look. I accidentally deleted the comma after email. There we go. Beautiful. Oh, that's so delicious. Now that is how you make a good select statement. Oh, this should be a comment, by the way, which takes 2 dashes, not 1. Now the select statement is extremely, extremely powerful. Honestly, without the select statement, databases would be useless. Some people focus their entire career on just select statements. So it's a big, big topic, but it's extremely valuable. So that's all I got for select statements in this video. Pretty simple, but nice and to the point. So thank you for watching. Please be sure to subscribe. Check the description for any links. And also, be sure to check out the next video. Thank you, and peace out. Welcome back to Caleb the Video Maker 2. So far, you've created tables, you've inserted data, you've selected data, but how do you actually go about updating data? For example, what if this Caleb Curry here wants to change his email address? How do we go about doing that in SQL? Well, it's actually pretty simple. We use an update statement. So the syntax is easy. You just put the column name, and then generally on the next line, you say set the column name equal to some value. And let me just scroll down a little bit so we can see a little better. And here is where we type the new value for the email. So we could say new email at email.com. Now, before you run this, please, 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 please be careful, okay? If you run this, there's like a 50% chance you'll get fired because this will literally update every single email address in the entire table. So you always have to do one more thing, and that is use a where clause. So now we specify which rows we want to update, and we have to do some kind of comparison. So we can do something like where email equals, and also these should probably be in single quotes, and say caleb@email.com. So what this is going to do is update the person who has the email caleb@email.com. So let's run this and make sure it works. Put semicolon. And it ran, so now we can select everything from users. Check the results. And the email is now new email at email.com. So it worked. Great. We could use this to our advantage to fill in some of this null data. Let's say we wanted to give Dylan an email. We might write something like this. Update users, set email equal to dylan@email.com. But how do we go about actually deciding which row? Well, he doesn't have an email, so he can't do this. So you might think, let's use his first name. So we'd say where first name equals Dylan. This will work for now, but this has a very serious problem in that in the future we might have multiple Dylans. And even if you made this where clause more complex to say, where the first name is Dylan and the last name is Johnson, well, we could have multiple Dylan Johnsons. So this is why the primary key is so essential. Instead of using this where clause for the first or last name, we can use the user ID. So what we could say is where user ID equals 4. So when we're doing an update statement and we're just doing it on one row, we always want to use the primary key or a unique column. So we can be very specific about what row we're trying to update. Let's run this, make sure it works. Okay, it ran successfully. Now let's select from the table. And now Dylan has an email. Awesome, Dylan. Now you fit in. How does it feel? And that is a general summary of the update statement. I know it's super simple, but that's always a great thing, right? So one thing I wanted to mention to you is the term data manipulation language. And that is what we've been focusing on these last couple videos with the insert, select, and update. But there is one more piece that we need to cover, and that is the delete. This is how we get rid of data inside of a table. That's what we're going to be talking about in the next video. So thank you guys. Be sure to subscribe, check the description, click like, all that good stuff. Thank you, and I'll see you in the next video. Peace! Welcome back to Caleb the Video Maker 2. This video we are going to be talking about one of my favorite things, deleting data. I don't know why, but I always get this satisfaction when I delete a bunch of stuff. So I'm going to express that satisfaction in excitement to teach you guys how to delete stuff. So it's very simple. All you do is say delete from, and then say the table, users, and then what we do is use the where clause immediately, and we make some kind of condition to decide what rows we want to delete. Now, just like I mentioned, you're likely to get fired using the update statement. Well, you're doubly like to get fired with the delete statement, so be extra super careful. Here, we want to make sure it's something that's going to only delete what we want to delete and not delete everything. So if you just do this, well then, I hope you enjoyed your job. So we need to make sure we have that where clause. So who do you want to delete? Yeah. He has some null data, and that bothers me, so I'm going to delete you, Dylan. I'm going to delete you. So we'll just say user ID equals 4. It ran successfully, so my thought is that he is deleted. So I'm going to run this statement up here to select the data. And you can see, he is gone. That's what you get for having nulls in my beautiful null-free table. You ruined it. Okay, let's do some other stuff. Let's make a where clause that's a little bit more complex. So let's insert some data, and this is going to teach you guys something new. You can actually insert multiple rows at one time using this syntax. So let's insert that data. Just to make sure it's in there, we will select from the table. All right, there we go. And what I want to do is delete everybody who does not have a verified email. So we say delete from users, where, and then we say is verified equals false. And you can see it ran successfully. Let's run the select statement just to make sure they got deleted. And they're gone. Please be extremely careful for this. There is no undo button, so you gotta be very cautious. Now, if you remember what I mentioned in the previous video with this here, the data manipulation language, we have covered the big 4 pieces of data manipulation language. So now you're basically a database pro. Go apply for tons of database jobs. But if they ask you why you don't really know that much, don't tell them it was because you watched my videos. This is literally just the basics. There's so much more, but this will get your feet wet, get you started, and now you kind of have a little bit of experience with all of the pieces. Now we're going to go back into some conceptual stuff for a while, because now we know how to create tables, but we want to make sure we create tables in the proper way. So we're going to get into database design, which is a pretty general topic. It applies to most database management systems. So once you learn it, you can apply it to all the other database systems out there that are relational. So yeah guys, that's all I got for you right now. Thanks for watching. Hopefully you enjoyed it. Be sure to subscribe, click like, check the links in the description, and I'll see you in the next video. Peace out. Welcome back to your Db2 tutorial series. Now this video is going to begin our discussion on database design. Now those of you who have been subscribed for a while, you know I love database design and relationships. So dating advice 101, here we go. The very first thing when we're talking about relationships is what in the world is a relationship? Why do we want to learn about it if we don't really understand what it is? I think a lot of people forget that part. They just start explaining the different types of relationships, but they don't really explain why or what for or anything like that. So let's just take a step back and learn a little bit more detail before we go in and start explaining things. One word that is essential to know when it comes to databases is entity. An entity is just a thing. Now, when we store something in a database, it's called an entity. But the thing is we store about that thing, like, the attributes of that thing, those are called attributes. So the attribute describes the entity. And in fact, we can have multiple attributes describing one entity. This is obviously very general, using entity and attribute and all kinds of fancy words, but essentially what you need to know is that sometimes we are going to be storing something as the object, and other times we're going to be storing things as something describing the object. Trust me, that'll make more sense. Just give me a minute. So a relationship is when some piece of data depends on another piece of data. So in this situation, if we're trying to store some data about something, you can say this data depends on the entity. If you wanted to make this, a little bit more concrete, we could have a user, and one of his attributes could be his username or his email. These obviously describe the user. The email that we're talking about depends on what user we're talking about. The username depends on what user we're talking about. So that kind of breaks down the whole dependency thing inside of databases. Now, what is a relationship? Well, a relationship is just describing different ways we can structure these dependencies. So the three types of relationships are one-to-one, one-to-many, and many-to-many. The first type of relationship is just a one-to-one relationship, and it's actually very, 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 very easy. The other two get a little bit more complex because then we're talking about relationships between tables. So for example, if we have a users table, and let's say these users can post comments on some kind of shopping website or something, well then we might have a comments table. Well, we need a way to associate who posted the comment, and that is where the relationship comes in. That is a more advanced relationship, and that's what we'll be talking about in the next two videos. But let's start now with just the one-to-one relationship. So yeah, I'm using the technical words like one-to-one without really explaining what that means, but I'm going to explain that now, and then when we talk about one-to-many and many-to-many, you already have that foundation and it'll make a lot more sense. Okay, seriously, this is like super easy, you might even be disappointed. A one-to-one relationship is literally just an attribute describing some entity. So in the example we had earlier, we had a user and an email. That's a perfect example. This email depends on the user. So let's just make this a little bit more concrete by giving it an actual user, and let's just say his email is caleb@email.com. The term one-to-one comes up because we have one attribute describing one entity. This one entity is being described specifically in email terms by only one email. So in a one-to-one relationship, you can only have one email for one user. That means if we have another user over here, it would not follow one-to-one rules if this girl also shared this email. That is not allowed. Additionally, we cannot have Caleb have two emails. This would be illegal in a one-to-one relationship. And you might think, well, hey, what if I want my users to be able to have multiple emails? Well, that is actually what the one-to-many and also going further, the many-to-many relationships are for. A lot of this just depends on how you want to structure your database. Sometimes it's a yes, no, black, white kind of thing. Other times it's a gray area where the database designer or the customer who's giving you the rules makes the decisions. So for example, you could design your database as a one-to-one with this, where a user can only have one email and that email can only be used by one user, or you could have it a different way where a user can have two emails or three emails or unlimited emails and so forth. Once you understand how to design the different relationships, it allows you to decide how to structure your database. And actually later on when we start talking about something called database normalization, well, a lot of this relationship stuff is foundational to that normalization, and if you get the relationships right, the problems with the normalization goes away. Now, if you haven't studied normalization, that's totally fine. Don't worry about it. We'll get to that soon. But you might be reviewing and you might have already had some experience with normalization, so I'm just giving you that as, little teaser. So if we want to design a one-to-one relationship, meaning that this is illegal and this person cannot share an email, here's cannot share an email, as you set up a table and you put the attribute as one column in this table. So now that we have the table, we can put a row in this table to describe this specific entity. And that is how you design a one-to-one relationship. Now once you get into some more of the advanced database design, you can tinker with the uniqueness of this column. So for example, if you wanted to allow another person to share an email, well then you could do it that way, or you can make it to where all the emails have to be unique. All of those things are things you can customize. So don't freak out about all of the details right now. What's important is that you get the general structure. And when I say one-to-one, you should think of one table with a column. That means this here is also a one-to-one relationship. So the first name depends on the user, the last name depends on the user, and the email depends on the user. As I mentioned with the more advanced stuff, well, even though a first name might be repeated a couple times, in general, you think of a name as describing one person, so you don't have to be like super anal with everything. It would be totally okay to have some repeating data here, because if I have another Caleb with, a different last name, well, this is describing a different person. So this Caleb is like a different Caleb. But we're getting into some detail that is, way beyond 101 database design. So don't worry about all that for right now. The most important thing is understand entity attribute. Boom, there you go. Now, in the next video, we're going to be talking about the one-to-many relationship, and that gets a little bit more complex, but that's going to be a lot of fun, so I'm excited. Be sure to check it out and be sure to subscribe. Check out the description where I'm going to have a lot of useful links, including a link to a blog post that describes this with some beautiful illustrations and all kinds of cool stuff. So check it out, be sure to subscribe, and I will see you in the next video. Peace. Welcome back to your Db2 tutorial series. This video we are going to be talking about one-to-many relationships. This video and a lot of the upcoming videos are general database design concepts and just database concepts in general, not necessarily relating to design. And all of these things are important when you're working with a database system. Fortunately, this information is very universal, so once you learn it with a Db2 database, you can apply it to any other database system out there that is relational. That being said, I am trying to teach these concepts in the context of a Db2 database. So some of the specific details might vary a little bit from database to database. The overall concepts are very universal. So as we go through these videos, even though we might not be talking specifically how to do something in Db2, all of this is extremely foundational for successfully working with a Db2 database. So let's get started with one-to-many relationships. As a review from the previous video, a one-to-one relationship is a relationship between an entity and an attribute. Well now, in a one-to-many relationship, we're having relationships between multiple entities. Generally, this is going to be structured in a way that there is a parent. In this situation, we have a parent entity that's going to be referenced by multiple child entities. This is the structure of a one-to-many relationship. And the reason it's one-to-many is because there is one entity up here and potentially many entities down here. There are some restrictions when it comes to one-to-many relationships. So this entity could not reference another parent. This would be illegal and just can't happen. So that'll make a little bit more sense once we go into a little bit more detail, but just for now know that a one-to-many relationship is many entities referencing one entity. So let's say we have a premium website where you can buy these memberships. And generally when you go to a membership website, they're going to have 3 tiers. One that's really super cheap but has like no features. One in the middle where you get a little bit of everything, and that's usually the most popular. And then you got like the premium one that costs a whole lot. Well, let's kind of mimic that and see how we would design that as a one-to-many relationship. You see, there are 3 different options when it comes to the membership, and this user gets to choose one. So let's say he picks bronze. Well, this other user, she might pick gold. The important thing to realize though is that one user can't pick multiple membership levels, and 2 different users could, if they wanted, reference the same membership level. So in this situation, we have a one-to-many relationship. That's because we have one entity over here, which would be the parent, and then 2 children entities that are going to reference that parent. How do we actually structure this in a database? Well, this is where primary and foreign keys come in. The parent is going to have a primary key, and let's just say that value is 1. Well, each one of these children are going to reference that primary key using a foreign key. So the value of that foreign key is going to be 1. And that makes that association between this one and this one over here. And that's how you kind of connect things. If we wanted to structure this in tables, it would look something like this. Every single table has a primary key, which forces every single row to be unique. So these are the columns. So if you were to actually look at data, it would be structured like this, where the columns are here. But for simplicity, we kind of design it where the columns are one after the other, and this is generally known as an entity relationship diagram, and it just allows us to structure the columns of our tables. So the user table is going to have a primary key, and the membership table is going to have a primary key. This here is a foreign key that references this primary key. And essentially what that means is every single value for this membership ID column has to be a value from this column over here. The membership rows would look something like this, where we have the ID and we have the value of whatever that ID is. Then over here you would have one user with a membership ID. So the user with the ID of 1 references the bronze. Or you could have a user with the ID of 2 reference gold. And it's impossible to put something like a 4, because you see this value here has nowhere to reference. So that would not be allowed to be put into the database. And that's the benefit of having foreign keys, is that they add those restrictions. That's all I got for you for one-to-many relationships. In the next video, we are going to be talking about many-to-many relationships. And that's actually a problem in databases because it's not very easy to design a many-to-many relationship. But I'm going to be teaching you the trick so that way you know what to do. So thanks for watching, guys. Please be sure to subscribe. Check out the links for some important links. Check out the description for some important links. Thank you, and I will see you in the next video. Peace. Welcome back. It's your many-to-many tutorial series for Db2. Now, like I said in the previous video, a lot of this concept stuff is generalized, so there's not a whole lot of Db2 specific things in here, but it's just good to learn it in the context of some database system. So let's get started with many-to-many relationships inside of Db2. The previous two videos talked about one-to-one relationships and one-to-many relationships, and those are easy, okay? Many-to-many relationships is where things get complicated. Unfortunately, it's one of the most common relationships you're going to find when you analyze the real world and the data that you're going to need to store in a database, so you need to get familiar with how you do it. In the end, you're going to have 3 tables. So if you think back to one-to-one, we had 1 table. In a one-to-many, we had 2 tables. In a many-to-many, we have 3 tables. The reason that is because when you have a many-to-many, what we're going to do is break that up into 2 one-to-manys. And if you remember from the previous video, one-to-many uses 2 tables. So how does this add up exactly? I said a many-to-many is 3 tables, but we're going to break it into 2 one-to-many tables. It seems like 4 if you ask me. But the reality is one of these tables is going to be shared. So it's going to be sort of like this. One of the 2 tables over here, and then the other one in the middle, and one for over here. So I know that's kind of confusing, so just ignore that. I'm going to draw this out and it's going to make a whole lot of sense. To illustrate a many-to-many relationship, I am going to give you a completely made-up example. Let's say we're working with that website and you have users. This is one of them websites where you can put your interests in and it changes the content accordingly. So what that means is the database needs a way to keep track of what stuff people are interested in. So there might be some categories out there like technology, science, art, and so forth that people can choose from this list of categories and receive content related to those things. So to start, we're going to have a user table. This will have a user ID. And now the question is, do we store the interest in here? Well, no, you don't. And here's the reason why. If we store the interest in here as a column, well, what if you had multiple interests? You'd have to store them as comma-separated values or some other weird hack, which is not going to work well because then it's not easy to say, oh, give me all of the users interested in technology. Because when you get their interest, it's just a huge list of a bunch of interests. So you need to break that off into another table. So let's go over here and make an interests table. So this is going to have an interest ID and then the actual interest value. So now, did this really fix anything? Because now we can go in here and say, oh, let's say we have an interest ID. This is still going to be a problem because you can only put one interest ID in there if it's a foreign key. Or if you make it to where you can put multiple, it's still going to be a comma-separated value. So you'd have like, oh, I'm interested in 1, 2, 5, and 7. But that's not super helpful because you still have the same exact problem as just listing them out by name. So how do we get around this problem? Well, this is where the third table comes in. We're actually going to make a table that goes in between these two, and this is known as the intermediary table. This is going to have at least 2 columns, and these columns are going to represent the parent. So we have 2 parents here, and that is going to be the one side of a one-to-many relationship. This is what I meant earlier when I said there's going to be a shared table. The parent is going to be 2 parents in one table. And the way we're going to name this is we're going to take whatever table this is, and let's say we're going to make it singular. So it would be user underscore and then interests plural. And what this table is going to do is just list all of the associations between certain users and certain interests. The reason this works is because we can have one user in this column as many times as we want. So this is going to be the user ID column. And let's just kind of list these out the normal way as both of these have them. We'd have a user ID, and then we'd have an interest ID. The user ID can be repeated as many times as you want, and the interest ID can be repeated as many times as you want. So essentially we have it where we have users and interests. We can have it to where one user has multiple interests and a specific interest has multiple users interested in it. Let's just look at what this might look like inside of this table. We might have it where user 1 is interested in interest number 1. User 1 is interested in the interest number 2. User 2 is interested in interest number 1, and user 2 is interested in interest number 2. So if you want to see this a little bit more clearly, we could say this is this guy over here, and this is this gal over here, and we have two interests over here. So this 1 is going to reference the science, and the 2 is going to reference the art. This kind of shows the many-to-many relationship, and this is the proper way to structure it. Well, that's kind of a general overview of the one-to-one, one-to-many, and many-to-many relationships. If you have any questions at all, please leave them in the comments below. Please be sure to subscribe, check out the description for some useful links, and as always, subscribe, and I'll see you in the next video. Peace. What's happening? This is where we start talking about database normalization. Now, when it comes to database normalization, you have to understand that there is a continuum. So a continuum is basically an entire range of possible values, I guess. Over here we have undesigned, and then over here we have completely designed. So when we're talking about databases, you need to realize that there is a happy medium in here that you try to go for. Generally, when you get over here to completely designed, your database is extremely complex. But if you go over here to undesigned, well, then your database is a giant piece of garbage. So a lot of the stuff we're going to be talking about in the next 3 videos is up to you to decide how far we want to take this. So we design our databases in these stages called normal forms. And if we were to put these normal forms on this continuum, you would have first normal form, second normal form, third normal form, and then there's some extra normal forms down here which make the complexity a lot higher. So generally I like to stop here at third normal form. I think that's like the perfect place to stop, where your database is not too complex, but it's also extremely well designed to avoid bad data. So that's what we're going to be doing in the next couple videos. First normal form, second normal form, and third normal form. Now I know I've been blabbering about these normal forms and I haven't really even explained them that well, so let's just start from the beginning with first normal form. What is first normal form? Well, it's the very first step of database design. Now, make sure you watch the relationship videos and the previous videos because the normal forms kind of build upon that, and a lot of the problems with these normal forms are basically automatically fixed when you design your relationships properly. Not everything is going to be perfect, but if you get the relationships down, doing the normal forms is a lot easier. So let's get started. First normal form has some rules that we need to follow. The first rule is that every column in a table describes only one thing. The next thing is that every value for that column contains only one piece of data. So if we had a column interests, this is like a dead giveaway because it's plural. So this does not meet rule 1. So rule number 1, columns describe one thing. This is breaking that rule. So let's say we try to fix that and we just make it interest. So now we have this table, and one of the columns in here is interest. So we have a users table and we're only allowed one interest here. Well, let's say someone, goes in there and inserts multiple interests for one single column, just like that. Well, this is actually breaking rule 2. So rule 2 essentially says there can only be one value per row for that column. And an additional rule is that you should only have one row per entity. So this refers to one specific user. So essentially, if you wanted to encapsulate everything for first normal form, you would say it follows the rule of 1. So columns describe one thing. There's one value per row for that column, and every single row describes only one entity. If you find that you want to store multiple interests or something in here, well, that's where I said the relationships are going to help you because you'll understand how to structure that. A more common example that breaks first normal form is having a column name. So name, is that one thing? Well, the other term for being one thing is atomic. So think indivisible, because you know, atoms can't be split, right? Okay, so this is really broken up into two things. We have the first name and the last name. This is an example that you might want to split up into two columns, or three if you want the middle. Some people decide, hey, I'm just going to put it in one column and we can't query by last name. But if you break it up into first and last name, you can do queries saying like, select everything from the users where the user's last name is blah blah. That kind of thing is harder to do if you store the first and last name inside of one column. Another common example is the address. So the address is actually not atomic. If you think of what an address is, it's usually a street or a street number, a state, and then a zip code. Well, if you wanted to get all of the data within a certain zip code range, it wouldn't be easy to do if you just stored one column address. So you always want to try and break things up into the smallest pieces as possible. This follows the first rule that I mentioned of first normal form, where a column describes only one thing: a street address, a state, and a zip code. Pretty good. If you want to extend that rule of one thing a little bit more to make your database really good, well then just apply it to some other things. A table should describe only one thing, or one type of thing would be a better word. So users. The table is kind of the exception. Usually I make tables plural. And it's controversial, but I like to have them plural. So we are describing one thing, the user. Then every single row is unique, describing only one user. You can kind of enforce that by having a primary key. So a primary key is just a unique value for every single row. Well, that means every value of the primary key is only used one time. Additionally, you're only going to have one primary key column. That one primary key value describes exclusively one entity. So if you tried to put one entity in the table twice, that's not something you want to do. You just don't do that. Okay, stop. Don't do it. One entity gets only one primary key, and a primary key describes only one entity. So yeah guys, that's first normal form, pretty super easy, I know, but that's okay. We're gonna go on to second normal form in the next video, and that's gonna amp up the difficulty. So put on your big boy pants because we're just gonna dive in and have some fun. So thank you for watching, please be sure to subscribe, and check out the description for any useful links, and I will see you in the next video. Welcome back to your Db2 tutorial series. A couple of videos ago, I discussed many-to-many relationships and how they need an intermediary table. The example I gave was users listing things they were interested in. So we had a table like this. And these are both foreign keys referencing another table. And you're probably wondering why I'm going all over this. Well, this is where you're going to run into second normal form problems. It's when you have something known as a composite primary key. Now, a composite primary key, the word composite is just a fancy word for humans to use, but the database doesn't actually use that word. So just know that when I say composite, that's not a keyword, okay? It's just a word to describe the type of primary key. And that type of primary key is the combination of multiple primary keys or just columns. So, for example, we can make the combination of these be the primary key. And the way that works is that the user ID, it can have repeating values all at once. Because you know, primary keys, you're not supposed to have repeating values, but this here is actually a foreign key. And foreign keys allow repeating values because you can have multiple references to the same primary key. And this down here is a foreign key as well. So we can have multiple interest ID in the table. The trick though is that you have to keep the combination of a user ID and the interest ID unique. So if we write out this data, we might have a 1 and a 1, 1, 2, 2, 1, 2, 2, for example. So these both reference one entity, these both reference one entity, these both reference one entity, and these both reference one entity. So there's repeating data in both columns, but the thing is, the combination is never repeated. Once we have 1, 1, you can't repeat that. Once you have 1, 2, you can't repeat that. So that is how a composite primary key works. And when you define a composite primary key in DB2, you're going to put that at the bottom of your create table statement as if it was another column, but it's not. So it would look like this. This comma here is telling DB2 that we're going to have 2 columns in our primary key. This has to be done at the table level. So that means you're going to have your other columns up here. We haven't done a ton of SQL in these videos, but I did put a lot of examples on my website, so make sure you check that out. The link is going to be in the description, and it'll update continually, so if you go there and you're finding not a ton of content, well, always check back regularly because I'm always updating it with new content. Alright, I'm getting a little off topic though. We're talking about second normal form. Second normal form deals with something called partial dependencies. If you think back to the one-to-one relationships video and the other relationships videos, we talked about attributes depending on an entity. They describe an entity. Well, the same thing comes up here when we're talking about partial dependencies. We're talking about things describing the primary key, but only part of the primary key. So if that doesn't make any sense at all, that's okay. Essentially, imagine we have another column in here, but that column only really describes the interest section and not the user ID. It only describes part of that primary key. So let's say these interests have categories. We could say in here, interest category. And when we do this, we introduce a partial dependency in our database. Because if you think about this, the user really doesn't matter at all in this situation. Let's say we go in here and change the interest now from C++ programming to acrylic painting, for example. Well, the interest category might change from computer science to art. So there's definitely a dependency on this interest ID, but not the user ID. How do you fix this though? We've recognized we have a partial dependency. The way we fix it is that we break off into another table. If we don't already have one, in this situation we probably do, and that's going to be the interest table. This category here needs to be moved into this table. And just get that out of the middle table. You don't need that here in the intermediary table. It doesn't belong. So we fixed our problem here. Now this interest is going to have a category, which, you know, that could be referenced from another table, like a category table if we really wanted. So what kind of columns can we put in this table legally? Only columns that depend on both of the primary key pieces. So for example, if you recorded when this association between a user and an interest was started. So for example, you join the website, 2 weeks later, you say, hey, I'm interested in computer science. Well, then it puts a timestamp saying, oh, this guy became interested in computer science at this time. Well, that's actually relevant to both the user and the interest because it's recording when a user became interested in something. So anytime you have something that relates to both of these and wouldn't really make sense in the user table and wouldn't really make sense in the interest table, you can put it in here as a column inside of the intermediary table between the many-to-many relationship. So I know this is kind of super complex. Second normal form is one of the hardest normal forms, especially because it really doesn't come up a whole lot, only when you have many-to-many relationships and you're dealing with storing things in the intermediary table. If you want to be on the safe side, just try not to design your tables to where you have extra columns in an intermediary table. And there, you don't have a problem anymore. But then that means you can't store anything about this primary key. So, you know, you gotta balance. Once you figure it out, then you can go in here, put columns in here, and make sure that your data is structured correctly. So thanks guys. If you have any questions, please leave a comment and be sure to check out the description. I have links for downloading DB2 and checking out my website. DB2 has been a good database to me, so I would encourage you to try it out and apply what I'm talking about here to your database in DB2. Thanks guys, and I'll see you in the next video. Peace out. Welcome back to your DB2 tutorial series. This is Caleb from Caleb the Video Maker 2. This video is going to be over third normal form. So this is the last normal form I have enough energy to care about, so we're going to stop after this one and move on to something else. Once you get beyond third normal form, it's almost like nitpicking, like, oh, this thing's basically good enough, but I'm going to make you change it anyways. Personal opinion, just throwing that out there. So I think third normal form is more than adequate to consider your database normalized. Alright, I'll quit wasting your time. Let's get started. What exactly is third normal form? Well, if you remember in the previous video, if you watched it, I had an intermediary table for user interest. And one of the columns that I tried to put in that table was an interest category. And then I was like, oh, this doesn't really belong here. Let's move that to the interest table. What we have is an interest table that looks something like this. So we have three columns, the interest ID, the actual interest value, and then the category that the interest belongs to. Like I said in the previous video, this could be a foreign key to a category table if you want to set that up. For now, you can just leave it as a varchar, for example, and just type in your category. And now let's say we add a column to this. This is a violation of third normal form. But I actually haven't even explained what third normal form is, so I should probably do that first. Third normal form deals with something called transitive dependencies. Essentially what a transitive dependency is when a column depends on the primary key, as it should in normal database design, but it does so through another column. If you think about switching a specific interest, so let's think of an interest. I'm interested in computer science. That might be in the category STEM, science, technology, engineering, and math, right? Well, if we describe that, we would say like, oh, this is a category for all things relevant to science, technology, engineering, and math, including blah, 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 just a description of whatever the category describes. And you can decide whether that description is useful or not, but for this example, assume we decided we're going to have a category description. Now, if we change the interest we're talking about to something else, like, you know, acrylic painting, well, now we're going to be talking about art. So the category might be art. And the description would say, oh, anything relating to the creation or production of whatever, you know, that would be the description of the category. So you can see when we change the interest, the category description also changes, because we switched from the interest from computer science to acrylic painting, and in the process the category description changed. So this category description does depend on the interest, but it does it transitively, which means through another column, like this. So when you get this hop here, you have a transitive dependency. The way you fix this is by going from the entity and going up one hop, and whatever this attribute is, you're going to take that and make it an entity in its own table. And now you can take this dependency right here and move it over here, and now since it'll be referring directly to the category, it's not a transitive dependency. This is just a normal dependency. But how do we fix this mess over here? What you do is you replace this with a category ID. And that is going to reference this category ID over here. So that's your foreign key reference. Then you're just going to delete this category description because it's not needed in this interest table. And this makes sense. We don't want to have this in here because we're going to have the category description in here for every single interest. That doesn't make sense. We really only need the category description one time, once for each category. So that is how you fix third normal form and get rid of transitive dependencies. If you have a chain where you don't just have 3 dependencies, but you have 4 or 5, just follow that process through all of them. You start with just going up one dependency, breaking that off into a new table, and then move all the other dependencies that are connected to that into that table. And then you just repeat the process. Go to the next dependency, move that into a new table, and so forth. So yeah, there you go guys, that's first normal form, second normal form, and third normal form. So thank you for watching. If you've enjoyed these videos, please click like, subscribe, check out the description for some links, go give Db2 a try. I'm out of things to say, so I will see you in the next video. Peace. Welcome back everyone to your Db2 tutorial series. Now so far we have covered a lot of information when it comes to database design. I know some of you guys think I go into way too much detail when it comes to database design, but personally I think it is foundational to everything we do with a relational database. Because of that, I got a couple more videos for you on database design. Just the relationships and the normal forms are not enough. So these upcoming videos are going to teach you how to enforce certain rules on your database to have the most data integrity. So that brings up a term for you guys, data integrity. If you say somebody has integrity, You think of that person as an honest person. They're consistent. You know who they are. They don't act differently in different situations. Well, the same kind of thing can apply with data. So if we're talking about data having integrity, you can trust the data to be accurate. You're not going to have any kind of inconsistencies throughout your database. Essentially, with data integrity, you can just assure yourself that the data you're working with is the most up-to-date, it's correct, and it's trustworthy. This is an overarching term for a couple different types of data integrity. So that's what we're going to be talking about in the next 3 videos. And this one is the first one. So the very first type of integrity is entity integrity. A lot of this is going to be review and pretty simple if you've watched the rest of the series, so don't expect something that's completely breathtaking. But I am going to give you some extra tips just to make sure you truly understand the concepts and what you should do to your database to ensure your database is up to standards. So first off, let me show you a bad example of a database table. Here is an example table for users. Let's throw some data in here. Let's say we have an Amy. We'll give her the last name White. And we'll say her email is amy@email.com. Now let's say we have another row here. And this is another Amy White with her email amywhite@email.com. And this brings up the interesting question, is this the same Amy with 2 emails? Or are these 2 separate Amys? And in this situation, you can't really tell. Now when we do our database design that we've done in the last previous videos, you should know that you should never have 2 rows describing the same entity. So my heart is telling me that these are 2 separate Amy's. From this table, there's not a very good way to distinguish them, unless you can say that all these emails are unique, and Amy's not going to be going in here and making multiple emails. Generally, to enforce uniqueness, we need a primary key. Now, a primary key is just a column that has unique data in every single row. It also determines how the data is structured in your table. Often it's going to be sorted by the primary key. Now generally, I suggest just using an ID field or a column. So I'd have like a user ID and then just use generated numbers that count upwards. Alternatively, you can use what's known as a natural key, which has real world meaning, such as an email. You could make all these emails unique, meaning you could individually pick an Amy using their email. If you didn't have this user ID here or this email and you wanted to talk about a specific Amy White, you can't because there's not enough information to distinguish the Amy Whites. So you always need a primary key for the primary purpose of making sure every single row is unique in your table. Now generally, primary keys are going to follow these 3 rules. The data is going to be unique, which I just mentioned. The next thing is the data must be not null. And what that means is you can't have the absence of a value. So let's say we brought this column back and we had a 1 here, but we didn't have anything right there. You would say that this entry is null. Well, that's unacceptable for primary keys. So you can actually label a column as not null, and it will prevent you from leaving that blank. Additionally, you're probably going to want to pick data that doesn't change. With this, I generally avoid natural keys such as emails because Amy might want to go change her email, and that's just going to ruin everything. So generally, I like what's known as surrogate keys or generated keys, but if they do change, it's not the end of the world, it's just generally frowned upon. That concludes entity integrity. In conclusion, it's literally just saying we need a way to say this is an entity and this is an entity, not the same entity. You need to be able to uniquely identify each entity inside of a table. If you want a 1-sentence summary of all of that, give a table a primary key. Boom, done. You understand entity integrity. Thank you guys for watching. In the next video, we are going to be talking about referential integrity. This is one that is extremely important if you're going to be working with complex relational database systems that have multiple tables. Db2 gives you a lot of ways to protect the relationships between tables. So that's what we're going to be talking about in the next video. So catch you then. Oh, and don't forget to subscribe and check out the description for some good links. There'll be a link to download Db2 and also check out the next video. See ya. What's up, everyone? It's Caleb for Caleb the Video Maker 2! In this video, we're going to be talking about referential integrity. Okay, so yeah, let's just think about this. If we didn't have referential integrity, what horrible, horrible things are going to happen with our database? So you go through the database normalization, you break your tables up and all that good stuff, but then the problem is you don't go through the effort to make foreign keys, and you just hope that everyone's going to use your database correctly. Or you say, oh, well, the software is going to use the database correctly. You are setting yourself up for failure or a miserable life or death or both. Wait, that was 3 things. Okay, anyways, let's go through an example. So I gave you this example a little bit ago. Let's say you have users and you have members. Now, one specific user has the ID of 1. Now, there's 3 types of memberships. 1 is going to be bronze, 2 silver, and 3 gold. Well, this user is going to reference one of the memberships. So let's say this user puts a 4. The problem is there's no membership with that ID. So this is literally pointing to nothing. With foreign keys, this kind of thing cannot happen. And that's what referential integrity is. All of our references have integrity. When you look at this here, without any kind of references or without this membership table, you can be assured that that 4 references something. It has integrity. You get rid of a foreign key, now you got problems. And you don't want problems, so make sure you use foreign keys. Foreign keys are going to be like, no bro, you can't use a 4 because that doesn't exist over here. So that whole concept is called a referential constraint. A constraint restricts the data to certain values, specifically values that exist over here as the primary keys, if that's the column we're referencing. So if this column references here, well now we're only allowed to use 1, 2, or 3. But that's not all referential constraints do. Referential constraints also dictate what happens when you go and delete data. For example, if this here was a 3, what happens if we went and just deleted this row? Do you know what happens? What is Db2 going to say? Honestly, I have no idea what it's going to say, but I do know that it's going to not let you. I think. Anyways, the 3 cannot be deleted because we have a child referencing it. These kinds of rules can be configured when you create referential constraints. So when you make a foreign key, there are some default rules that are applied to your references. Well, you can configure those. Specifically, there's 2 kinds of referential constraints. There's onUpdate constraints and onDelete constraints. So when you make a foreign key, if you created this column as a foreign key, I have code examples of how to do that on my website. That is going to configure the onUpdate to do something and the onDelete to do something. So both of these are packaged inside of a foreign key. So it's not like you have to make a foreign key for the updating and a foreign key for the deleting. You just make one foreign key and then you can do all this stuff inside of that. So this example of deleting this 3 refers specifically to this delete. What happens when we delete? The same thing happens with an update. What happens if we change this 3 to a 4? Which generally primary keys should never change, but that's besides the point. The onUpdate is going to kick in then. What happens to this value over here? You see what I'm saying? For example, it could update it. That would be cascading. There are some specific options that I'm going to talk about, so let's do that now. So once again, the 2 categories were onUpdate and onDelete. There actually is a third one, onInsert, which I actually described already, I just didn't give it a definition. So when you insert data, it verifies that there is a parent with that value. So if you remember, the user ID had to reference a membership ID. So there's onInsert, onUpdate, onDelete. Now let's talk a little bit more specifically about, let's go with onDelete. A lot of these things are going to apply to the other ones, so you can kind of move these around. But let's start with onDelete, and it'll make a lot of sense because that one's the most easy to think about. So the first option is restrict/no action. So these are 2 separate ones. There is a minor difference that if you want to know, you can look it up, but it's over my head, so I'm just going to move on. Essentially, these do basically the same thing. If you try to delete a parent when onDelete is set to restrict, it's only going to let you delete that parent if there's no child referencing it. So if you have an entity here, and it's not referenced by anything, and then you try to delete that row, it will let you. But if you have another entity down here, this would be the child, and it references this entity, well now it's not going to let you because it's saying, hey, you can't delete this entity because it's being referenced. So it would say, nope, you can't delete that row. You could delete this row though because it's not being referenced by anything. The other option is cascade. This is one of the most dangerous things of all time, so be warned. If you want to lose your job, make sure you use cascade. Essentially with cascade is if you delete this parent, it's going to delete any children that reference it. The problem is you don't always know everything that's being referenced by everything. So you might delete something intending just to make a minor change, and that might cascade through your database, deleting all kinds of important information, you know? The last option is set null. And what this will do is it will set this reference to null when we delete the parent. So if we have columns, you know, like let's say it's in the user table, so we have a membership ID, and let's say this value is 1 and this value is 1. Well, over in the membership table, if we deleted the row with this ID, in the user table, this would just be replaced with null. In the user table, this would show up as this. Now this is okay if you allow orphaned children. So this is called an orphan row, this right here. In some situations it's appropriate to have orphaned rows, other times it's not. That's a decision that is going to be up to you, or your boss, or someone else, you know? So, make sure you're careful to understand how your tables are going to be used. Does it make sense for a user to not have a membership? Well, maybe they signed up and, you know, they got rid of their membership and they still have an account, but they just can't use any of the stuff. Well, then it would make sense to allow nulls here, and you might set it to set null when you delete. Otherwise, you might set it to restrict if you don't want orphaned rows. Now, if you don't want nulls in this ever, then you're going to want to set this foreign key as not null. And this is basically saying this child has to have a parent for that column. That's a summary for onDelete. You can apply it essentially the same way to onUpdate, but now you guys just get an overview of how the referential integrity works and different ways you can configure it. Thank you guys for watching. Hopefully that gave you a great introduction to referential integrity. The next video is going to be talking about a new type of integrity, so be sure to check that out unless you're super lame, and in that case, you should check it out anyways because you need to learn the material. So please be sure to check that out, subscribe, like the videos, and check the descriptions for some useful links to download Db2 and to check out my website. Thank you, and I'll see you in the next video. Peace out. What's up, everyone? I think this is literally the first time I've ever started a video on this side, but I don't really know why I'm telling you that. Anywho, this video is going to be over domain integrity. So the very first thing we need to discuss is, what is this fancy domain word? You know, like, is that like a web address, or what is that? Well, essentially, domain is the rules for data, what is allowed and what's not allowed. So there are numerous ways we can enforce what data is allowed in a specific column. Some of these are very general ways that are allowed in most database systems. For example, data types are a very great way to have domain integrity. So let me take a step back. If we have domain integrity, what we are saying is that our data is within the allowed values. If we do not have domain integrity, then we cannot trust our data to be in a set of different values or within a certain range of values. So the data types, these are a very general way to restrict data. So for example, you can have a numeric data type and that's going to reject string data. You can have a date data type and that's going to force every single value to be of a date format. You can get very specific on what kind of data you're looking for by using the appropriate data type. So as you get into some more database design and some more advanced database concepts, make sure you understand the data types. By having the correct data types, you can make sure your data has integrity. The other way are some general rules. You could use not null. This is an example of a constraint. That would basically force every single row to have a value for that column. You could use unique. That's going to force every single value for that column to be unique, meaning once a value is used, another row cannot use that value. Now, additionally, you can use what's known as a check constraint. So check constraints are pretty awesome and they're not available in all database systems, so I'm pretty psyched that Db2 has them. But check constraints allow us to be extremely specific on what data is allowed inside of our column. So if you want to be specific on, oh, we can only use values in this range or only these specific options, well then you might want to look into a check constraint. Now, if you are not using check constraints, there is kind of like an old-fashioned way of doing something similar to a check constraint, and that's generally called a lookup table, also known as a validation table. A classic example of this is having the states in a table and then referencing them. So if over here you have a state table, and then in this table every single row is a state that someone could live in, well then you could only allow those values using a foreign key. So this kind of goes back to the one-to-many relationships. If you decide to set it up this way, you can force a column to have a value in that state table. So over here you could have a state column, and you could say this references the state table and then the state ID column. And now every single value in this column is going to have to be a row in this state table. So that's an example of a validation table. Nothing too crazy in this video. I know it was really super short, but those are your general guidelines on how you get domain integrity. I didn't go into a ton of detail on how to do all of it, but the point is here is to teach you the basics so then you know where to look if you are trying to do something specific. If you want something more to research, definitely highly recommend the check constraints, because that's going to allow you to be very picky with what kind of data gets in your database. So thank you guys for watching. Please be sure to subscribe. Check the description for some links. I'll give you a link from my website and also to download Db2. Be sure to subscribe for upcoming content. Like this video, and I'll see you in the next one. And yeah guys, that's all we got for database design, at least for now. It's been a journey, but we made it. We made it together. We made it. So thank you, and I'll see you in the next video. Which actually, I lied. The next video is going to be applying some stuff we've been talking about in the last previous videos. So after that, we're good. Welcome back everyone to Caleb the Video Maker 2. This is going to be an on-screen video just talking about some of the different constraints we can apply to tables. I'm kind of just going with it right now, so I don't really have a whole lot planned. Thus, if my examples are kind of pretty awful, I apologize ahead of time. The very first thing is I wanted to talk about some of the column level constraints. Essentially what that is, it's an attribute you apply to a column that changes what kind of data is allowed. This is referring to domain integrity. So let's just create a table, and we are going to call this table parent, and you'll see why in a minute. So the very first thing you're going to want to do when you create a table is create a primary key, which we've discussed in previous videos, but just as a refresher, you can do something like this. And then give it a data type, we'll just give it int, and then you say not null, and then primary key. So this int is a data type that restricts the type of data allowed in this column. That is the first layer of defense. Not null is another attribute we can apply that further restricts the type of data, so now we're not going to be able to insert nothing. We always have to insert a value for this column. And obviously the primary key is going to add the extra constraint of every value being unique. So this is an index, and we haven't really talked a whole lot about indexes, but indexes are an extremely important part of databases. And once you get the database design down, I'd say the next thing to learn are indexes. So when you create a primary key, you're automatically indexing this column. And what that means is that it's optimized to use this column for joins and for all kinds of different queries. Another thing you can do is just say unique. So if I run this, you can see it works, and this is going to make a unique constraint, which also is going to create an index. So let's go to the administer and then go to tables, table explorer. Going to give this a refresh, and there's our table right there. So we click that, go over here to indexes, and then there's a bunch of information about this index here. So I click that, and you can see this is a unique index. Now if I go back to the SQL, and what I'm going to do is I'm going to drop this table, and then I'm going to recreate this without that index. Now what I'm going to do is go back to my tables, go back to my table, do a refresh, and you can see there is now no indexes on that table. So when we add the unique constraint, we're actually adding an index. Very similar to adding a primary key, slightly different. The primary key actually determines the way the data is retrieved. So to see that, if we go to this table users, let's go to the data here. So here's some data we had in the previous example. Often this is going to be sorted by the user ID. What that means is if you go and select something by the ID, it's very easy for the database to find it because it can just go to that number. Rather, if you selected something by, the last name, Well, it has to do a scan of the table. So I'm kind of getting a little bit off topic onto indexes, but they're extremely important, and essentially what I wanted you to know is that sometimes when we do a little column attribute here like unique, we're doing a little bit more than we might think. This is actually indexing our column. But I'm going to go back to primary key. Now what I want to do is create another table and teach you guys a little bit more about foreign keys. So we're going to say create table, and we'll name this one child. And in here we are going to have a child ID. So this will be int not null primary key. And we're also going to have a foreign key which references the parent. This will be of type int, and I'm going to make it nullable, which means I'm not going to use the not null keyword. And then what I do is I say references, and then I put the table name, parent, and then in parentheses, I am going to put the column name, parent ID. Run that, and you can, oh, it failed. Why did it fail? I think it might be because of the names, so I will name this parent table, and then I will name this one child table for consistency. And down here, I will change this to parent table. Okay, create that table, and then create this table. Great, haha. Okay, I got it working, sorry. So this creates a foreign key constraint. So now if we go into administer and then look at the tables, get rid of all this junk. Let's look for the child table. Give it a refresh. Child table right there. What we can do is go to the constraints, and you can see we have a primary key and a foreign key. We're also going to have an index because we created a primary key. So if we go into this foreign key, we can get a little bit more information about it. And you can see on the delete, it's no action. On the update, it's no action. Meaning you're not able to delete the parent without deleting all the children manually yourself. Now you understand a little bit more about indexes, constraints, and viewing that stuff inside of Data Server Manager. You can also go to administer and look at all your constraints here. Obviously this is not going to be nearly as helpful because you didn't give your constraints fancy cool names like the rest of these in here, which you can do that if you want. Just look up how to do that if you need. But until then, we're just not going to worry about it because I think we're doing very good. Thank you guys for watching. Hopefully you enjoyed the content, and be sure to subscribe, like the video, and peace out.